Dijkstra's algorithm.
Dijkstra's algorithm is an algorithm to find the shortest path between nodes. In this example, we have 5 different nodes, each represented with a circle. The nodes are labeled A, B, C, D, and E, respectively, and each have different edge lengths.
We have a list of the unvisited nodes and track the distance between the source node to each individual node. In this case, we're starting at node A, so the distance is 0. The distance to the other nodes from A is unknown, so they begin at infinity. First, we get A, which is the source node, and mark it as visited. Then we on-queue the adjacent nodes of A, which are B and C, and update the distances. To B, it is 5. To C, it is 2. Since we use a min heap, we dequeue C because it is a shorter distance, and mark C as visited.
Now we find the nodes adjacent to C, and NQ is adjacent nodes. From A to C to D is 7, and from A to C to E gives us 9. Now we choose the node with the smallest distance, in this case it's B, then we dequeue B and then mark it as visited. Now we queue the unvisited nodes adjacent to B, which is just D. We note the path going from A to C to B to D with a distance of 9, but since we have found a shorter path from A to C to D with a distance of 7, we ignore A to C to B to D, remove it from the queue, and mark D as a visited node.
Now we look at the adjacent nodes of D and queue up E. The distance to E from A is 9, which is the shortest possible, so we dequeue E and mark it as visited.
So the shortest path to C is 2. The shortest path to B is A to C to B, so it's 2 plus 3. The shortest path to D is A to C to D, which is 2 plus 5. And the shortest path to E is A to C to D to E, which is 2 plus 5 plus 2.
Now that we have all the possible paths, even though the min heap isn't empty, the loop will terminate because all of the nodes have been visited.
The time complexity of this is O of number of edges times log n, and the space complexity is O of n.